Welcome to today's geometry class. This is for MCS Geometry, Saxon textbook, lesson 80, which is on page 524. We will be covering surface areas and volumes of spheres. First, please pause your recording and do your warm-up problems, and then we'll continue. Welcome back. Warm-up. A three-dimensional figure is called a solid, something we've known for a long time. We are supposed to find the surface area and volume of a cube. The cube, as listed over here, has a side of 7 feet. And so I write that the surface area is 6 times the side squared, and that the volume equals the sides cubed. So it would be 6 times 7 squared, and the answer is in feet squared, and this would be 7 cubed feet cubed. And also find the surface area and volume of a cylinder to the nearest 0.08, which is hundredths of an inch, which means that we will use the decimal approximation for pi. The surface area equals 2 pi r squared plus 2 pi rh. And the volume equals 4 times, that's a pi. Pi r squared times the h. The volume is the base of the circle, the base of the figure, times its height. I didn't get my calculator out to do that, and I can have those answers for you. But on 524, they want to introduce a definition of a sphere. You know that it resembles a ball, or in the space inside, but a sphere is a set of points in space that are a fixed distance from a given point. That is called the center of the sphere. The equation for the surface area is given as S in this book, and I will be using SA for surface area and capital A. These are capital S's and capital A's, and so our surface area equals 4 pi times r squared. Please put that in your smart sheet. And the volume is listed as V, capital V again, equals 4/3 pi r cubed. In our lesson, we will also be having the surface area and volume of a hemisphere. That will be 1/2 the surface area, or 1/2 the volume. But wait for the extra trick that we need to put in. Example 1 on page 524 is to find the surface area in terms of pi, which means no approximation. Surface area equation again is 4 pi r squared. We substitute in 4 pi, and we have over in our drawing that the radius is 5 inches, so 5 inches squared, which equals 25 times 4, which is 100 pi inches squared for the surface area. Yes, if you wanted to determine how much material you needed to make the ball, you would have to have 100 pi inches squared for a 10-inch diameter ball. Now we're supposed to find the volume of a sphere with a radius of 13 feet. We are going to write of a sphere. Now mind you, a radius of 13 feet means that the radius is larger than from your floor to ceiling. So this is a large sphere. A room, might be another room name for it, and the volume equals 4/3 pi r cubed. So we have 4/3 pi, 13 cubed, and the feet cubed. Go ahead and use your calculator, and you should get 9,202 and 77 feet cubed. The new term is a hemisphere, which is a half of a sphere, and a great circle, the circle on the sphere that divides the sphere into two hemispheres. So we cut it in half, and we have an extra circle, and that's an extra portion of surface area we need to count. So now we're going to find the volume and surface area of the hemisphere with a 12 centimeter diameter. Well, first we have to change our diameter to a radius. Diameter equals 12 centimeters, radius equals 6 centimeters. And now we can plug that in to find our volume. Volume equals 4/3 pi 6 centimeters cubed, which is 904.78 centimeters cubed. And now we need to divide it by 2, and we get 452.39 centimeters cubed. Let's go on to the surface area of the hemisphere. And remember, we have to do something a little bit different. Step 1, we're going to find the surface area of a full sphere. Step 2, divide the surface area in half of the hemisphere. Step 3, add the surface area of the great circle that has been found because it is a hemisphere. And of course, that is simply the area of a circle, which is pi r squared. So step 1, 4 pi times 6 centimeters quantity squared. It's approximately 452.39 centimeters squared. Step 2, divide it in half. Divide by 2. Which is approximately 226.20 centimeters squared. Step 3, begin with your previous area, 226.20, plus pi times the radius squared, 6 centimeters quantity squared. In your calculator, that turns out to be 339.30 centimeters squared. At this point, go back and try that yourself. Slow it down. I took a great deal of time, maybe even an hour, preparing the lesson ahead of time. So if you don't get something right away, please stop, slow it down, review, go back. Or you can continue on to your lesson practice. And let's get started.